Welcome to anyone watching, it's Craig at mysimpit.co.uk and welcome to part 19 of the front dash build. In this video we're going to look at the engine monitoring instrument panel. We'll take a look back at a prototype of this build previously and some improvements we'll now make to that, and we'll look at the build of it up until the point it's ready to install into the front dash. Let's buckle up. As regards this engine monitoring instrument panel, I did previously make a prototype of this and I detailed it in a video which I've put online. The link to that is in the description below. And within that video I went into quite some detail around exactly the way in which it was wired and coded and how it was made to work and function on an RS485 network. At this point I'm now looking to take the learnings from that prototype and make something that's got a number of improvements, and that would then be the final panel for the engine monitoring instruments that I will implement into the Simpit. So we'll start now by looking back at the original prototype as built and start to talk through the improvements and upgrades I'm going to look to make to that within a new panel, within a new EMI unit, which can then be integrated into the Simpit. So let's just take a moment now to have a close-up look at the prototype panel as built. This was the first of any of the panels I built for the front dash, and I picked the EMI because I was keen to gain some experience with an RS485 network, but also running various stepper motors, something that I'd not done previously. So the EMI seemed like the perfect one because it was the most densely populated panel in terms of the number of gauges of any of them in the front dash. I did run this panel for quite a large number of hours as I brought it online, just to test it as thoroughly as I could, and during that time it ran without any issues. I do, however, see a good opportunity here to improve certain parts of it as I build the actual EMI unit that I'll use. In terms of the improvements I plan to make, there's three main ones. The first type of improvement relates to the aesthetic of the front view, and something that I do plan to do is make sure that on the next EMI panel I do, that these cutouts here, all of these cutouts are painted. That just like in the real aircraft you've got bezels, but in this case I want the bezels to be coloured too, so it's properly in keeping with what's in the sim and the real aircraft. And also there was a little bit of lettering just on these top bits here that just got missed off on the prototype, just to indicate whether it relates to the left or the right engine, so I do plan to include those now. The second type of improvement I'm looking to make is to build this as a self-contained unit. So if we have a look at the picture here of the original network, we've got the EMI panel here, at the back of which we've got all the slave devices, and then we've got this separate unit over here that I've built, which was the master of that network. Now what I'm looking to do is integrate the RS485 master that we can see here directly into the new version of this panel I make, and that will be achieved through using the PCB version of the master I've produced recently, also using other parts of the front dash. Well, I'll have one just for this and it'll be built at the rear. And that ties in with the second part of this improvement, which is I don't want the overall footprint of the rear to be any greater than it is now, despite the fact I'll have integrated this into it. So I'll use a redesigned version of the PCB slaves, and each of those will allow 2 gauges to be run. So it means it's one slave, which is one Arduino per 2 stepper motors. So that more compact wiring and approach to driving the gauges will create the space then for the PCB master to be put in place. The third type of improvement I'm looking to make I've put under practical maintenance, and that's made up of two parts. The first part is I want the new EMI unit to have removable needle pointers. So on the prototype I attached the pointers to the shaft of the stepper motor by a dab of glue, and whilst that all worked fine, if it had been that for maintenance I'd needed to pull the back away to change something or replace a stepper, I couldn't have done that without pulling the pointers off, and if they were glued in place it really did risk damaging the stepper itself. So the new unit will have removable pointers. And the second thing will be that the stepper motors themselves, where suspended at the rear of the panel, will be done so in such a way that it'll be easier to remove and replace them. So with the improvements outlined, we can now get to work. And we start by looking at a redesign of the original CAD/CAM file just so it'll fit the front dash frame. As always, I need to prepare some acrylic to sand it and paint it. I always like to cut as much as I can out of the acrylic and minimise any waste material. I've not really had any problems with panels being damaged when I've been building them, but it's always handy to have a second one, particularly if you're building one and running certain tests on the other. I really do love the whole machining process. I think after all the time spent designing the CAD file, it's really great to look at it actually being physically brought to life. I am finding that 3D printing is playing a much bigger role all the time in all of my panels, particularly at the rear of them where it's used to create brackets and hold things in place and mount them all as needed. I'd also love to have access to and at some point get some time in on a laser cutter engraver machine and see what kind of results I can get with that. If anyone watching has had experience of making panels both with laser engravers and a CNC machine, I'd be interested for you to put some comments below the video of which you felt was best and why. So we have now the machined acrylic. Just needs a bit of a tidy up, but as always looks absolutely great. Great job from the CNC, and we've got a few pointers produced on the left there. Now, one of the first types of improvements that I was looking to make was around the aesthetic of the fascia, and one of those was to paint the inner rim of the cutouts. And we can see that done now, and I'd took time to mask the front just to be sure that when I'm painting the inner rim I wouldn't be marking the front fascia that you would see. A further part of the improved aesthetic is to produce bezels. We can see here a 3D print that I've done of that. We'll just take a close look at that. It's got an indentation on the underside there for the holding the little circular piece of acrylic as a window. And speaking of which, I've cut out a number of circular pieces of acrylic, each of which will just then click into the back of that bezel. We can start to get an idea of what that's going to look like. Yeah, I'm happy with that, so let's go ahead and 3D print a whole load more. Sorted. I've printed quite a few spares here because as we now go to the process of adding all the smoothing compound and then we're going to sand it and paint it, there might be a few that don't quite end up with the right finish, so of a whole number of them, I've done 20 odd, we'll be able to pick the best ones and they're the ones we'll put in place. We can see them now after they've been sanded, gives it that flat surface that we need. Let's just have a closer look at that. Obviously it's not going to look great at this point, but what we have now is a flatter, smoother surface. And we can now start to prime them and then we'll paint them. And again, if we have a close-up look, we can start to see them coming along now. Still early doors, but heading in the right direction. Following the bezels being primed and painted black, I can now start to mask them and then paint through the individual colours of yellow, red and green to give it the look that we see in the sim. So after applying the first few colours to some of the bezels, I'll just mount them in place and just check that they've got the kind of finish that I'm after. On the whole, it's looking pretty good, so I can now go through the process of marking out where I want to apply each different bit of colour, masking it all up, spraying a few times over that one bit, letting it dry, taking all the masking off, and then reapplying it and just working my way through until all of the various bits are painted. What we can see here is one of the bezels has got quite a large surface area to be painted green, and I'm now just peeling off the masking tape, which was to protect the various parts of it, and we can see here it did a good job and gave quite a nice sharp line and finish. In the background you can see where I've marked out where the various colours will sit on the bezels. So I'll speed this bit up now, and what we're looking at is me going through a number of bezels I've painted to see how they've turned out, what the finish is like. This was one part of this panel that you couldn't just say sit down and say I've got half a day, I was going to do the whole thing. With it being the painting and needing it to dry, it was just a little bit of time each day but spread over a good week or so. I think it was a good move to use spray paint. I have found that some results can be a bit mixed when you use a brush. And we can see now all of the finished bezels. At this point they do look a bit reflective and shiny, and I will now be adding a coat of sealant to it, which will give it a bit of a matte finish as well as protecting it. So here we have the 12 bezels fully painted, finished, and they've got the sealant on. They've also got the small circular acrylic windows in place, and we're ready now to mount them onto this faceplate, which we've also got the lettering on, if we have a look at that as well, which was an improvement aesthetically we did want over the prototype. We'll just have a close look at these now they're finished. Obviously just making sure with the acrylic windows I give them a bit of a wipe over just so it's got rid of any unnecessary fingerprints. So we now arrive at the finished faceplate, and we'll have a close look at that. But I'm really pleased with that. I definitely think, although it did take a fair amount of time because there was a design of the bezels and the whole process of putting all the colours in place, but definitely a much better aesthetic than the prototype. We now move on to all of the wiring, and we start off with all of the bare components and just lay them all out, and we're now going to go through a process doing a whole load of soldering to put them all together. We have the improved version of the slave PCB, which has thicker traces. It's designed to drive 2 steppers per board now. We've got the nanos, the easy driver boards, which I'm going to use upgraded connectors on as well, and then all of the X27 steppers. And I've just spent a bit of time just marking out the coils and the positive and negative terminals of those, just so later on when I'm soldering everything up I don't accidentally solder the wrong wire to the wrong connector. A little time later we can now see the various components all assembled and soldered together. A good thing is that these improved PCBs now have an RJ45 socket, so it standardises all the connections. I can just get any Ethernet cable or any one I make, any one I've used before, and it just plugs in the same either end. Whereas on the prototype it was an RJ45 socket at the one end to the master, and then at the slave it was a totally different 8-pin connector. I can now start putting some of the different layers together. So the black MDF layer at the bottom acts as a spacer, and then we can see the tidied up cutout and machined acrylic. Extra holes are machined into the spacer level, so when the bezels are connected to what would be the top layer and it sits on this, obviously it will need those holes to sit into. I mentioned improvements around accessibility from a maintenance point of view, so here I'm just trying different ways of holding the steppers in place where it's easy to change if I needed to. And then with that decided and I'm clear on that approach, I can now wire up the back of all of the steppers so we can now install them. We'll just take a moment to take a close look at one of these. I think I mentioned it in another video recently, I do intend at some point to design a PCB that these will just sit on, and that will obviously save a lot of the time and effort that goes into soldering all the wires on and whatnot, and it would probably give it a far more secure connection too, although this has worked well on the prototype and it should work just fine for this one. Well, that's all the steppers in place, and we can now just come in for a bit of a closer look. Yeah, and now we can start building up the rear layers. Now this is where we can save some space. We've got a layer of acrylic, which on the one side's got all of the slaves and the easy driver boards, and on the reverse of that side it also has a backlighting. And unlike the prototype, we're now using half as many slave PCBs. We spoke earlier about another improvement to the accessibility in terms of the pointer needle, because on the prototype I'd glued that on, which wouldn't have worked well at all if I'd needed to remove the back of the panel, because as I would have pulled that away I would have had to have first pulled the pointers back off. So here I've laid out what are the parts that make up the new pointer, and then I assemble it together now. So what we have now is a type of pointer which can be easily removed, which is good from a maintenance point of view. Even on the prototype, I never actually, despite all the use I had from it, needed to ever remove any of the pointers, but like all things, it's always nice to have the choice, particularly if upgrades might come to mind in the future. So we now take the finished pointers and we can secure those all in place. And what we have now is the completed EMI panel. So what we'll do, we'll just take a moment now to have a close look at this. And the final layer we can see now is the actual PCB master, which is all part of the actual unit. So there won't be a great deal of cables to connect this. There'll be the one to the PC, and then there'll just be a 12-volt power in. I'll use two power ins, one for the backlighting and one to power the RS485 network. So overall, a good finish. I'm happy with that. What I will do now, I'll just have a look at it side by side to the prototype, because after all, the whole purpose of building and rebuilding this EMI panel was to achieve those improvements, both aesthetically and in terms of the accessibility and other aspects of the wiring and design. So I think that looking at the prototype now, the front of it just looks so bare. I really do think that the raised profile of the bezels and the colour of them adds a lot. From the side perspective, we can see that the footprint is about the same on both, but the good thing is, whilst the footprint's the same, the new one is the whole unit, everything. It includes a master, it's the entire network with minimal cables to connect. The prototype, as we know, that had a whole series of cables, 12, which then ran a length to a whole of the unit. Looking at the back of the new EMI panel, you can see those orange RJ45 sockets, and that's because I have in mind to use some kind of power monitoring instrument just to be able to see how this new network is functioning. That's something I'll detail a bit more when we install it into the front dash. So that's the new EMI panel completed. I'm pleased with the improvements we've got in place, and we've managed to achieve all of the ones we outlined at the start of the video. In the next video in this series, we'll look at the installation of this panel into the front dash, and we'll bring it online and run a number of operation tests, and we'll also look at some monitoring instruments that will run alongside it just to see how it's working over the RS485 network. Thanks for watching.